So welcome to the lecture number 32. Today we'll go for some interaction between the server, the transaction server and the database server, and how they are communicate each of them with different peripherals. So okay, we'll start. So firstly, we have here the interconnection network architecture. At first, the bus architecture. What is the bus architecture? In a bus architecture, there might be several nodes. In the diagram you are showing here, there are 4 nodes here. So you can think that 4 nodes are 4 servers. So these servers are communicate through some single channel. So as it is a single channel, it is called the bus, and as it is communicating through the single channel, so there is no chance to have the to gain the parallelism of the system. And in the bus system, all the components are receiving data from the single communication channel, so it is something slower in transaction processing too. So in the mesh communication, in the mesh network interconnection network architecture, so the component are arranged as node in a grid, and each component is connected to the adjacent component. So what is happening here in the mesh components and the mesh network, the network it is working with, so it is basically having more than one connectivity. So if some network or if some connectivity is going lost, so another redundant connectivity is still alive, and these alive connection can gain the parallelism of the system. So in the hypercube, the hypercube is another type of network. Is basically some hybrid combination of the network, and this hypercube model is basically used for the where you are looking the network in a three-dimensional view. Here the 8 components, each of the components are connected to the another component with more than 2 connectivity, and this connectivity is represented through some whenever the transaction are globally distributed and globally distributed channel. Suppose like a transaction server having more than one connection to some hub. Suppose like you are buying some product from a website, and it may have multiple connection with the sellers and the payment gateway. So there are multiple direction can be happen through the same server through the different aspects. So this is the hypercube network. And if we looking for the parallel database architecture, there are 4 types of architecture. One is the shared memory, shared disk, shared nothing, and hierarchical. So in the shared memory, what is happening here, that is there are a lot of processor can be there. A lot of processor means a lot of system is working there, and they are working in parallelly with a lot of jobs. But the memory size is totally fixed, and memory they are all the processors are sharing as a single memory, which is a large memory. So what is happening here, the processor can gain the task and also send back the task in the memory, but they need not to access the software each of the time. So that is why, though they are connected to some bus network, but they are working in as the drives and the memories are also in the same bus network. So that is easily extremely efficient communication between the process, and the memory can be accessed by any processor without having to move to using the software. So but there is some laggings also, that is it having some lower degree of parallelism. It that is the one thing. And shared disk policy, it is basically each of the processor having each all different processors are sharing some disk with the same bus network. All processor can directly access all the disks via an interconnection network, but the processors have private memory. So all the processor having each of its memory. So here memory is the not the bottleneck point, but if some the advantage of this system is if some processor and some memories fail, so other processor can take back its work and can complete this task with the help of the disk. But this system also having some problem about the communication and intercommunication, because if some of the connection is lost between the drive and the processor, suppose like as it is a shared disk network, so if the bus communication is failed to the disk, so it will be make the disaster, because all the processor can be alive but they cannot uh, uh, communicate with this disk. So it is a problem here. The shared nothing, it is a high extent system, and it is basically used by the giant companies like Oracle and these sort of things. So here each of the processor having is memory and is disk, but it's a very expensive solution, because each of the system, each of the processor, if you think that it is a server, so each of the processor having its own disk and own memory, it make the increment of its cost of setup. But it is very much handful and very much efficient system if you think for a large scale of things. So main it also having some drawbacks about the cost of communication and non-local disk access, and different processor and different system cannot access its system without the interface of the software, and for each of the time it needs the permission to another processor to access its data. So that is the one problem here. And also one thing is that if one segment is going down, you cannot communicate through some other way to this segment. So that is might be the another problem of this system. So in the next slide we are going for the hierarchical design. So hierarchical design, what is happening, that the it combines the characteristics of the shared memory, shared disk and shared nothing policy. So the combination of this shared memory, shared disk and shared nothing policy, what is basically happening here is this is a hierarchical, or morely called it is a hybrid network, because you can mix up all of the models here. So this is the policy you can achieve more parallelism, and it is also reduce the complexity of the programming, such as such system by the distributed virtual memory architecture. So here you can see that there are three shared memory architecture is implemented in the same network through some bus connection. So this is how the hybrid connection or hybrid mesh network can be architect with some visionary design. So now the topic is the distributed system. So what is a distributed system? Distributed system is mean that the database are distributed in different geographical locations. So there are, you see here, three sites: site A, site B and site C. So these are three locations which may have servers, and they are interconnected to some network. But this problem is, if the network is going down or if the network is false, so the total site will be nowhere. You cannot locate these servers. So, but there might be some virtual connection also between the servers without the main core network. So they can use this redundant connection to server to access the data. So this is how the distributed system is work. So this mainly distributed database, two types is homogeneous and heterogeneous distributed database. Homogeneous means they all having the same software, but the data are split in different locations, suppose like Facebook. And heterogeneous distributed data means that all of the data and the database are using different softwares, but they are merged in a single point, or different sites are doing the same works or different schema. So this is the heterogeneous distributed database. And the difference between local and global transaction is, local transaction is happening with a single site and single system. Suppose like if you are doing if you are just transferring some money from your Bkash account to your friend's Bkash account, it's a local transaction. But if you buy some product from using your Bkash wallet, that is a global transaction, because you are buying some product from a different site and you are paying through some Bikash account, it's a different server. So these two servers are talking each other through some interface API. So this is how a global transaction is made. So these are the end of this chapter. So thank you for watching this video.